All right, what's going on, everybody? It's Kishner again, and let's get into the video for section 1.3, or topic 1, lesson 3. Should be on page 9 of your student companion to see this example in front of you. Um, so let's get into it. It says a music teacher needs to buy guitar strings for her class. At store A, the guitar strings cost $6 each, and at store B, the guitar strings are $20 for a pack of 4. Use your pen tool. I'm going to use my pen tool here to make graphs that show the income each store receives if the teacher needs 1 through 20 guitar strings. So, for example, there's $6 each. So we're going up by 20 or by 10s on the left-hand side here for store A, and up by 2s here. So at 1, we're at about 6. 2, we're at 12. 3, we're at 18. 4, we're at 24. 5, we're at 30. So that's a nice clean spot. 6, we're at 36, and so forth here. So I'm going to go ahead and just keep that pattern going a little bit here. 7, 42, 8, 48. You can see that. And that pattern's going to keep going. All the way up to 20, you're going to have 120, right? 20 times 6 is 120. So I'm going to go all the way up to that. Okay, so you can keep those going. You don't have to connect the dots here. You just got to keep them fairly linear. It doesn't ask for us to connect the dots. 10, 60, 11, 66, 12, 72, plus 6 is what? 78. 14, 78 plus 6 is 84. 15 is 90, even. 16 is 96. 17 would be 102. Then you get to 108. Then you get to 114. And then you get to 120. So there we go. There's all 20 spots. That took a little bit longer than I planned on it, but oh well. Now, store B is the long running one. At store B, the guitar strings are $20 for a pack of 4. So no matter if you buy 1, 2, 3, or 4, you're spending $20. Then if you buy another pack, you're going to spend $20 more, so you jump up to the $40 range for 5, 6, 7, and 8. Then you do that again for another 20 for 9, 10, 11, and 12. And then another 20 for 13, 14, 15, 16. Another 20 for 17, 18, 19, and 20. Now that's a weird looking function, but it is a function. So part B says describe the shape of the graph for store A. Describe the shape of the graph for store B. Why are the graphs different? Well, graph for store A is a straight line. Or it should be if I'd have graphed it a little more accurate. It's pretty much a straight line. Store B, we're going to say this. It jumps between flat sections. It kind of looks like steps. And I use the word steps on purpose here. We're going to get to that. Okay? So those are just two definitions. Why are the graphs different? Well, one is linear. Each price it goes up by per package, and here it goes up in groups of packages. So that's why they're different. Compare the graphs for store A and store B. For what number of guitar strings is it cheaper to buy for store B? We'll do this in class tomorrow, and we'll do habits of the mind in class as well. Okay? So go ahead and turn the page. Let's do this try it problem. Alani has a summer job as a lifeguard. She makes $8 per hour for up to 40 hours each week. If she works more than 40 hours a week, she makes 1.5 times her hourly pay. That's pretty much a real-world situation. 1.5 times for your overtime is about right. So let's look at this. Now, I'm first going to graph this equation. She makes $8 per hour for up to 40 hours. Okay, so let me label this graph here. These should be, actually, it should be, I labeled these wrong down here, so let me erase that. down here. Let's go up by hours worked. Let's go up by tens. 10, 20, 30, 40, 50, 60, and 70 hours. And this is money. So up to 40 hours, she's making $8 an hour. So I know that 0, 0 is a point, and that 8 times 40 is 240. So that'll be right in here. So I know I have a line doing that point right there. From here to here is 40 hours a week for 8 hours per hour. So 8 times 30 should be right at about, is that right? Yeah, 2, yeah, that's right. Okay. And I did that wrong. Nope. 8 times 4 is 320. I am silly. That should be up in there. There we go. That's 40 hours a week for $8 an hour. And then 1.5 times her pay. So 1.5 times her pay is $12 an hour. So we're going to get a graph that looks like it goes up like this. Okay? Now you notice it changes, but it's the same graph. So the question is, how much, or it says, notice the plot contains 2 linear segments with a slope that changes slightly at x equals 40. A function that has different rules for different parts of its domain is called piecewise function. So if we go back and actually write the equation, the red line, let's call it f of x, is just 40, or f of h, I guess we could say, is 40h. Okay, 40h. Once again, I'm wrong. It's 8h. I'm not thinking straight today. 8h for h is less than or equal to 40. Okay? And then we can go to the green. G of h would be 12h minus something. We don't know what that is yet, for h is greater than 40. Okay, we'd have to figure out where that's going to cross. And if you do, you're going to get 160. Okay, we're not worried about how we get that right now. That's a linear thing. But down here, we need it to plug in things here. This is a piecewise function. It's the same function. It's just got 2 parts to it. It's a piecewise function. This should be an h. Now, how much will Alani work if she earns 37 hours? So 37 hours, I'm going to plug it in to the 8h because it's less than 40. So really what I'm looking for is f of 37. Okay, f of 37 would be 8 times 37, which is 8 times 37, it's going to be just below 320. If you do it on a calculator, you get 296. So she would make $296. For 43 hours, you're going to plug it in to the f of 43, and that's going to be the 12 times 43 minus 160. Okay, and if you do that, you get 356. So she makes 356 hours, $356 if she works 43 hours. So she makes $40 more if she works 7 more hours. 6 more hours. That's right, 6 more hours. All right, go ahead and turn the page to the next try it, or go find the next try it in your book. This is the graph of a piecewise defined function. What are the domain and range? Over what intervals is the function increasing? Now, on this video, we're only going to do the A's on the video. We'll do the B parts in class. So don't worry about it. We're not doing every example. That would take a very long time. So, part A. Let's graph it. We're 2x plus 5. So let's go ahead and draw in some grid lines here. And I'm going to draw, it's going to be weird, but I'm going to draw this up here. Okay? I want you to kind of match mine here if you can. if yours isn't already drawn in. All right, kind of match mine. Now, we're on the line 2x plus 5 from -6 to -2. So what I'm looking right now is from -6, 1, 2, 3, 4, 5, -6 to -2. I'm on the line 2x plus 5. So I'm simply going to plug in -6 here. 2 times -6 is -12, plus 5 is -7. So at -6, I'm at -7. 1, 2, 3, 4, 5, 6, 7. So I'm here. And at -2, that's -4 plus 5 is 1. So I have a line right now going from -6 to -7. Okay? Sorry, -6, -7 to -2, 1. And then I do 2x squared minus 7 from -2 to 1. So now I'm looking, I'll use a different color here. From -2 to 1, I have a different function happening. And I'll plug in those points. At -2, get -2 squared is 4. Times 2 is 8. Minus 7 is 1. So we are right here. That's a good start. Let's plug in 0. That's going to get me -7. Because 0 cancels this out, gives me my y-intercept. And if I plug in 1, 1 squared is 1, times 2 is 2, minus 7 is -5. So right here at -5. So this is a parabola, and I knew that simply because it's a squared term. Okay. And then I have another line, -4 to -x from 1 to 3. So I'm going out to 3 this time. I'm just looking in there. I'm looking at my different domains. And I'm on the line -4 to minus x. So my y-intercept is going to be -4 if I was going to graph this, but I just plug in points. -4 minus 1. -4 minus 1 is -3. So if I plug in 1, I'm at -3. So I'm at -5. If I actually did the math right, you would see it's -5. And then up to 3, -4 minus 3 is -7. So now I have this graph. And this is a weird looking graph, but this is the actual graph. Okay? Now, we're going to talk about what are the domain and range here in a second. I will talk about that in class tomorrow. But if you want to try to graph B the same way I just did that, remember, I just plugged in my endpoints to see what happened. And that's how I got this graph. This is a piecewise function. It is a weird looking piecewise function, but it is a piecewise function. Let me fold that in a little bit bigger. There we go. All right. That's your first piecewise function where it goes one thing one way, and then all of a sudden it changes and does something else, and all of a sudden it does something else. That's based on these rules. I just went straight down the line. Your next try it says, what rule defines the function in each of the following graphs? So the way that I do this is realize I see 3 parts. I see part 1, part 2, and part 3. So I'm going to go down here and list 3 parts down here. Okay, I'm going to list 3 parts. And the way you write this is f of x equals this thing. Now, part 1 here looks like it's a straight line. So f of x equals is going to equal a constant function. Think of those parent functions I gave you on that last paper. So that looks like it's sitting right about 7. Okay, f of x is going to equal 7. This is part 1. Between, that looks like maybe -5 and -1 maybe? -2. -5 and -2. So this is true when -5 is less than or equal to x, which is less than or equal to -2. And I know they're both equals to because these dots are filled in. Okay, then we go on a line here. And let me move this thing. And it looks like it's crossing at about 5. So I know I'm going to have a line with a y-intercept of +5. And my slope appears to be, well, we go from -2, 7 to 3, 2. So if you do your math for your slope here, you're going to see that the slope is -1. So this is just going to be negative x plus 5. If you do the math, you're going to get the slope to be -1. You go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. And that's from -2 is less than or equal to x, which is less than or equal to 3. And here's the last one. It's a line that starts at, it looks like 4, 5, and goes to, if this is 4, 5, 6, 6, 9. So I immediately know my domain for this section is going to be between 4, and I'm going to put a less than symbol, x, and that's less than or equal to 6. 4 does not have a less than or equal to symbol because it's not colored in. Now, what's the equation of that line? I have to figure out the equation of that line. So we would do a little bit of math, and we'll do that tomorrow on part B. But if you do a little bit of math on this one, you're going to figure out the line is 4x minus 5. Now, remember, if you want to go ahead and try part B, go ahead and pause the video and try part B. We're going to check it tomorrow in class. All right, we have some tries left here, but I'm going to stop the video here because we're right at that magic round 15-minute mark. It's about 16 minutes right now. So make sure you copy down these examples, and I will see you guys tomorrow or the next day in class. This is Kistner out.